Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. We're going to go to the types of integral form, the definite versus indefinite. I've already talked a lot about indefinite already, so I just want to introduce definite integration now. So, but basically there are two types of integrals. We have the definite and indefinite. And before I proceed, I always like to say, and don't forget to like, share, and subscribe. Click the notification bell so that when I post new videos, you'll be the first person to know. All right, so there are two types of integrals. There are two types of integrals. Okay, number one, the first one is what we call the indefinite. Okay, so this is the type we're already conversant with. Indefinite integration. So for instance, I say integrate x cubed in respect to what? In respect to x. Okay, so we've talked about this a lot. We've talked about how to integrate this, and I gave you about 15 rules on that, and we've talked about playing around with this. Now, the second one I want to introduce here, okay, is what we call the definite integration. Now, the definite integration is exactly like the same thing, all right? But the only difference is that we have what we call the upper limit and we have the lower limits. Does that make sense? So you can have integrate x cubed between 4 and 1, where 4 here is the upper limit and 1 here is the lower limit. So that means in an indefinite integration where you have x, okay, a and b, for instance. So a here is the upper limit. And b here is the what? Is the lower limit. Are you seeing it? So we have the upper limit and the lower limit. All right. So before I proceed, I will want to give some, let's say, comparison. I want to just do a contrast between definite and indefinite integral forms so that we can all be on the same page. So let's assume I have this. So we want to do this. So let's say I'm going to draw a line here. So we can start. So we can say this is going to be for the definite, while this is going to be for the indefinite. So how do you compare both of them? All right. Now, the first thing you need to know is based on what they represent. Okay. So we're going to talk about based on what they represent. And I'm going to talk about in terms of both of them, what they represent. Now, the first one for definite, this represents a number. Okay. Then while in indefinite, the indefinite integral form represents, so this represents a number, which is the key thing to keep in mind, while this represents a function. Okay. Then also, one of the things again that the definite represents an area under the curve from the lower limit to an upper limit. Okay. So it represents an area under the curve. Now we're going to talk about this more in the subsequent videos, okay? From a lower limit to an upper limit. Okay? Now, while an indefinite, it aims to answer the question, what function, when differentiated, gives a particular function, okay? So it aims to answer the question of what function, when differentiated, give a particular function like f of x, okay? So that is the difference. So what the indefinite does, it aims to answer the question. What function, when differentiated, gives f of x. So what function, when differentiated, gives f of x? Okay, and that is that for that. So another one again is that I can talk about this in terms of characteristics. Okay, so I'm going to talk about this in terms of characteristics. So I'm going to go to the next page to do this. So I'm going to draw a line as well. Okay, and we have from this point. Points. Okay, so we have definite, and we're gonna have number 2 is the indefinite. All right. So in the previous one, we talked about in terms of what it represents, what we say represents a number. So now the next part now is that we want to talk about the B. We want to talk about in terms of the characteristics. Okay. So we want to talk about in terms of characteristics. So what are the characteristics of a definite and an indefinite, okay? How do they compare to each other, all right? So here, we're going to talk about in terms of the limits. So the definite has both upper and lower limits. So it has both lower and upper limits. All right, which are both constants. All right, so it has both the upper and lower limits, which are both constants. Okay. So for instance, you can have something like 3, 1, for example. You're differentiating x raised to power 4. Can you see? You have both upper and they have the lower limit. But for indefinite, there are no limits of integration. So here, there are no limits. So in this case, so we had the upper and lower limits, but here there are no limits of integration. So for example, when you are integrating, you just integrate x raised to the power 4, then you add a constant at the end, like what we did with as we were solving previously, okay? But for definite, you have numbers or you have a constant at the top and at the bottom. Now, the next thing here is as well is that when you're done solving definite, you're gonna have a definite number as an answer. So when you solve a definite integration, you're gonna have just one answer or a definite number as an answer. So you're gonna have, so definite has a definite number. So you see the keyword is that you have a definite number, all right? So it has a definite number as an answer. Okay. While for this, okay, the answer, you don't have a definite number. So, but usually you give an answer in terms of x with a corresponding constant. So, like if for instance we're solving this, you could using the integration, you would say it's 4x cubed plus c. So an answer in terms of x plus a definite constant. Okay, so plus a constant for that. But here you have for definite, you have a definite number. But here you don't have an indefinite number, you just have a constant in addition to the answer in terms of x, okay? So in this one, it gives an answer. Okay, with x, so there'll be x in the answer in it, okay? And the constant usually denoted as c. Okay, so for example, if you are integrating x4, it's going to become 4x3 plus c. So this is why we call it indefinite. So that was the reason why in the previous videos, when we're integrating with those rules, I will tell you that in the last step, you add c only if you're talking about indefinite, okay? All right, so then the last one, there's just one more characteristics I'm going to add here for indefinite is that it usually gives a general solution to a differential equation, and it's referred to as more as the general form of what? Integration. So it's usually, all right? So what happens here usually gives a general solution to the differential equation. Okay, and usually referred to as the general form of integration. Okay, it's usually referred to as the general form of integration. So in the characteristics for the definite, like I said, it has both the lower and upper limit, which are both constant, while for the indefinite, there are no limits. For definite, you have a definite number as an answer, but for indefinite, it gives the answer with x in it and a constant, usually denoted as c, all right? And also, usually the indefinite is usually referred to as the general form of what? Integration. All right, so the third part that we're going to talk about, just to make this interesting, I'm going to just pick an example. That will be the third part for this. I'm going to pick an example for this so that we can just to the third part just to solve. Now, don't worry. I'm going to have a session for indefinite integration, okay? So I'm going to have a session for both the definite and indefinite. So, but I've solved a lot of indefinite with all the rules already. So it's pretty much the same, but I'm going to make a video series on definite alone, all right? Because that is the part that I'm going to talk about. So let's say, for example, for a definite, it has an upper limit and it has a lower limit, and you're told to integrate x squared in respect to x. But for indefinite, you're just told to integrate what? X squared. Are you seeing it? So this is the difference between both of them. Now for indefinite, we've talked about indefinite severally already. So when you're doing this, I told you it's going to be x raised to power 2 plus 1 divided by 2 plus 1. And you now add what? C. So it's going to be x raised to power 3 divided by 3 plus C. So I've done this. I've talked about this in terms of the 15 rules. But I'm going to show you the steps about this. So basically, it's still the same thing. Okay. When you're doing a definite integration, so you integrate it the same way. So 3, 2. So you have x 2 plus 1 divided by 2 plus 1 now, and that is going to give you 3, 2, and we're going to have x 3 over 3. Now, in this case, we're not putting c, all right? So what happens then is that you now substitute the upper limit minus when you substitute the lower limit. Don't worry, I have a video for this. That we're going to talk about this in the next video, but I just want to give you a taste of what we're going to talk about. So you're going to put 3. So anywhere you see x, you put 3. So it's going to become 3 cubed divided by 3 minus, then the lower limits, you put a 2 there. You're going to be 2 cubed divided by 3. And then you now press your calculator. And the answer you will now get for each of these, when you press it, it should give you what? 19 over 3. So you can see when you solve a definite, you're going to get a definite number as the answer, while for indefinite, when you solve, you're going to get an answer in terms of x plus the constant, all right? Okay, so I've talked a lot about indefinite. So the next video now, I'm going to talk about how do we solve definite integration, all right? So that's what I'm going to talk about in the next video. So make sure you subscribe and click the notification bell so that when I post the next video on definite integration, you'll be the first person to know. All right, I'll see you soon in the next video.